everyone. Okay. Hello, everyone, and welcome to Asteroid Day 2021 event in Israel. This year, we'll have with us a famous planetary scientist that participated in more than 20 space missions, and in 8 of them, he was the principal investigator. But before we turn the mic to our honorable guest, we have some announcements to make. First of all, I want to thank my event production partners, Itai Leon, the incredible astrographics artist, for all the graphics he made for the event, Adi Saada, the manager of the Horizon community, the space teachers and professional community by ESA for the use of their Zoom platform and Facebook Live, and Maj Tabit for the help with the event organization. Asteroid Day Israel is the Israeli branch of the world-known Asteroid Day Initiative led by Asteroid Foundation in Luxembourg. Asteroid Day was recognized by the UN as the International Day to raise the public awareness about asteroids, both in the risk they pose to the planet and also the opportunity they provide for the exploration and mining resources. On June 30th, 1908, an asteroid exploded over Tunguska in Siberia. On February 15th, 2013, a smaller one exploded over the city of Chelyabinsk, also in Russia. Furthermore, we all grew up on the Bible story about Sodom and Gomorrah, in which God destroyed because of their sins. Recent studies by the archaeologist Stephen Collins that did extensive archaeological digs in the Bronze Era city of Tel El Hammam in Jordan claims that this is in fact the biblical city of Sodom, and an asteroid impact is what obliterated the city that was protected with stone walls 10 meters high and 5 meters thick in an instant. All of these events serve us as a reminder that we live together in the same country. Asteroids do not distinguish between different people. Therefore, we must work together to defend ourselves from asteroid threats. I want to repeat it in both in Hebrew and in Arabic. אנחנו גרים יחד במדינה אחת, אסטרואידים אינם מבחינים בין אנשים שונים, לכן עלינו לעבוד יחד כדי להגן על עצמנו מפני האסטרואידים. Maj, can you please tell it in Arabic? Maj is with us? Oh, okay. In Israel, we currently live in the Bereshit generation, an era of interest in the high-tech and space in which the anti-missile batteries, the Iron Dome, saved hundreds of lives. Bereshit, the first privately funded spacecraft, reached the moon, and we will soon see the second Israeli in space. The children of this generation will be the scientists, the engineers, and other professionals that will get humans back to the moon and greatly advance our space exploration in general and of asteroids in particular. So I hope that all of the audience that joined us today, and especially those kids, will learn something new and take us forward. So now back to our honorable guest, the principal investigator of New Horizons mission to Pluto and the Kuiper Belt, an engineer and a planetary scientist that was involved in more than 20 space missions, such as the Hubble Space Telescope, the Rosetta mission to Comet 67P, the Lunar Reconnaissance Orbiter, and many more. In 2007, he was listed among Time magazine's 100 most influential people in the world. And most importantly, is the proud father of 3 and has also Jewish roots. Let us welcome Dr. Alan Stern. Hi, Alan. Welcome to Asteroid Day Israel.
Thank you so much. I'm so excited to be here and honored as well, Victor. The topic of my presentation is not related to the serious threat of asteroids. It's about the results from the New Horizons mission that was the first to explore the Pluto system and the Kuiper Belt. And no one on the Zoom has to worry about Pluto or the Kuiper Belt being a hazard to the Earth. But nonetheless, the topic of asteroid impacts is a serious one. And I want to applaud all of you for your interest in it and for your advocacy for this important worldwide topic. Now I'm going to share my slides and I'll begin my presentation. Let me put it in full screen. All right, can you see my slides?
Yeah, okay.
Okay, so about New Horizons, which really scientifically has been an archaeological dig into the history of our solar system. To begin, I want to say that what I can tell you this morning, and it's still morning here, is only a small bit of the story of how New Horizons came to be and some of the results. And to tell more of the story, I collaborated with planetary scientist and author David Grinspoon a few years ago to publish this book, Chasing New Horizons, in 2018, which is the full story of how this mission came to be and some of the difficulties that we had, both politically and from an engineering and scientific perspective, some of the adventures that I don't have time to tell you about since the spacecraft has been launched and in flight, and more about the scientific results. So if you have an interest, you can find this online and in bookstores. But let me start by saying that of all those missions that Victor mentioned that I've been involved in, 29 now, New Horizons is by far my favorite. And I think that's true for most of us on the mission team. I hear it over and over again from flight controllers and engineers. I hear it from my colleagues on the science team that they've never been involved in something like New Horizons. And here's the reason why. It's truly an epic journey to the very frontier of our solar system. It's not just the first mission to visit Pluto, which is the archetype of a new class of planets, the dwarf planets, and the first mission to the Kuiper Belt, but it's the successor to the storied Voyager mission. And for scientists and engineers in my generation, we were too young, we were children and students when the first missions to all the other planets took place. In the 60s and 70s and 80s, NASA was launching the first missions to Mars and Venus, and then to Jupiter and Mercury, and then to Saturn, Uranus, and Neptune, concluding in 1989 with that Neptune flyby. And by the time we were professionals, scientists and engineers, there was only one first mission left, and that was the exploration of Pluto and the Kuiper Belt. And for all of us who are on it, we feel truly blessed to be a part of something that's so much larger than life and something that's worked out so well. And this has been a large project. 2,500 men and women in this country worked to design and build and fly New Horizons across the solar system. And it's still flying today. And we are looking for yet another flyby target. But before I do that, I want to give a little bit more background about myself, if you're interested. This is a picture of myself in front of the nose cone of the rocket that New Horizons was launched in. This is about a week before we launched the spacecraft, and there's New Horizons inside. And you can see the antenna at the top, the big dish, for example, and all of that gold foil that's multi-layer thermal insulation around the spacecraft. I'll tell you much more about the spacecraft as we go, but I wanted to give a little background on some of the other things that I have done in my career, and I'm happy when we do the Q&A to talk about some of that. I spent many years in the aviation side of aerospace. In fact, that's me on a nighttime mission with an instrument that I flew on the space shuttle, which I also flew as a crew member in NASA F-18 Hornets for 5 years to collect scientific data. And I flew in a whole variety of different high performance aircrafts, not just the Hornets, doing airborne astronomy. Additionally, well, that's the Hornet, in case you don't know the aircraft. But additionally, I was fortunate to go to the South Pole on a National Science Foundation expedition, where I also did astronomical research from one of the coolest places on Earth. And now, more recently, I have been selected by NASA to be the first researcher to fly on a commercial spaceflight mission. And we're expecting that to be next year. I'll be doing astronomical research from aboard a Virgin Galactic suborbital mission. We're already in the training for that, which includes centrifuges and zero-G flights, altitude chambers, and high-performance jet aircraft G training. But now I'm going to turn to the subject of the talk. And I'm showing this fuzzy dot, which is the best image of Pluto ever made before New Horizons. And I have to tell you, I was the principal investigator of this Hubble Space Telescope program, which was the first to actually resolve Pluto into anything more than a point source. And we wrote a number of scientific papers from this data. But you know, it's too blurry to really do any real geological science or atmospheric science. And this is why we send spacecraft to the planets, is because our Earth-based view is just not good enough, and we have to get up close to collect high-resolution data. Compare this image taken by the Hubble, the very best telescope in the world for this purpose, to an image made by New Horizons a few days before closest approach of Pluto. Meet Pluto. This is the planet that appeared so fuzzy in the Hubble Space Telescope image. In fact, this is the same hemisphere of the planet. And if you look closely, those bright pixels towards the bottom in the south are representing this very bright area, which we now call Sputnik Planitia. On Pluto, it's a massive glacier, the largest in the solar system. But I thought I'd start truly at the beginning. For those of you who are wondering, how did we get to do something like this? I have to tell you, it was a long path. Back in the late 1980s, when Voyager was making its flyby of Neptune, a group of young scientists, myself included, banded together to try to convince NASA that it should mount a mission to the unexplored planet Pluto to finish the first reconnaissance of the solar system. And NASA responded very positively and paid for the Jet Propulsion Lab to conduct a study of how we would go about doing that. It was called Pluto 350, but unfortunately, it never got off the drawing board. But NASA responded with a second study of a much larger and more ambitious mission called Mariner Mark II the very next year, but that became too expensive and it was canceled. So we started another small mission study called Pluto Fast Flyby, but it was poorly managed and was ultimately canceled. And as you can see, later in the 90s, we had another study called Pluto Express, but it didn't make it off the drawing board either. And I'm telling you this story because it took 12 years from 1989 until 2001 simply to get permission and funding to design and build a spacecraft that would actually go to the launch pad and then go across the solar system to explore Pluto. And it took a lot of persistence by a lot of people, but we never gave up and we succeeded. And we had a competition in the United States by NASA for proposal teams to write proposals with their designs and plans for how to explore Pluto. What you're seeing here is the cover to the New Horizons proposal that was turned in 2001. And if you can see me on video, the proposal was nearly 1,000 pages thick with engineering details, scientific plans, management plans, and so forth. And we competed with several other organizations in the United States, like the Jet Propulsion Lab. But our team, which was composed of the 5 organizations you see here in the bottom left, Ball Aerospace Company, my firm, the Southwest Research Institute, the Johns Hopkins Applied Physics Lab, NASA, and Stanford University, won that competition. And we were very fortunate to be selected to be NASA's team to design and build a mission to Pluto. And this is a cartoon of the spacecraft with the names and arrows pointing to each of the 7 scientific instruments that we built for the purpose of exploring Pluto. A little about this spacecraft. This is the same dish antenna that you saw in the picture inside the rocket a few minutes ago, it measures 2.3 meters in diameter. So that's the scale. The entire spacecraft is about the size of a baby grand piano, and very small compared to Voyager, our predecessor, largely due to miniaturization that had taken place in electronics and other spacecraft systems from the time Voyager was designed in the 1970s until New Horizons was designed in the early 2000s. This black device here, sort of cylindrical with blades on it, is a nuclear battery that powers the spacecraft, and it is used to power all spacecraft that go too far from the sun in order to use solar power. And then these are the 7 scientific instruments. Alice is an atmospheric spectrometer. Ralph is a color camera and surface mapping composition spectrometer. There's a student-built instrument to measure the rate of impacts of dust particles as we fly across the solar system to map out the distribution of dust in our solar system. Lori is a high magnification or long focal length camera for close-up imaging. And SWAP and Pepsi are particle spectrometers to measure gases and charged particles across the solar system and also emanating from Pluto's atmosphere. And finally, REX is a radio science experiment used to take the temperature of Pluto and its moons and our other flyby targets, and also to measure the temperature and pressure profile versus altitude in Pluto's atmosphere. And the title of this slide is Making Intelligent Compromises. And as we began to design and build New Horizons, we had to do a lot of that, primarily because we only had a certain amount of money and a certain amount of time to get it launched. And I was determined as the leader of the mission that unlike all those other missions that never got off the drawing board, the New Horizons would become a real spacecraft on a real rocket, and then it would be launched, even if we had to make compromises, and we did. There were instruments that we wished we could have added that we could not. We would have liked to have had more fuel, but we weren't able to fit that on the spacecraft. We would have liked to have a more capable communication system, but we couldn't afford it. But in the end, the spacecraft that we built was a very capable spacecraft, and the instruments that we were able to fly returned more data from Pluto than any previous first flyby of any planet by more than a factor of 10. Here's the New Horizons spacecraft on the factory floor during this assembly, and you see people around it for scale. And you can see my cursor, here's that high gain antenna again for communicating with the Earth. Here's the nuclear power generator. And then this is called the spacecraft bus. It's the body of the spacecraft, and inside of it are all of the systems that are needed for a flight across the solar system of several billion kilometers, taking a decade. So the communication system, the computers, the power distribution system, the thermal management system, the propulsion system are all inside. In fact, there are 2 of each of those so that we have backup systems in case the primary develops some problems in flight. And then the 7 scientific instruments like SWAP and Pepsi that I showed you before are mounted on the outside where they have good viewing. We launched New Horizons on the 19th of January, 2006. These are pictures of that launch on a very large rocket called an Atlas V. This is the most powerful version of the Atlas V, which some of you may know, called the Atlas V 551. For scale here, these solid rocket motors are about 25 meters in length, and the payload bay where New Horizons sits inside is itself more than 30 meters in length. So we had a good launch, and the spacecraft was propelled to record speed. It became the fastest spacecraft ever launched, so fast that it crossed the orbit of the moon, not in 3 days like Apollo astronauts launched at 25,000 miles an hour, but in just 9 hours, we crossed the orbit of the moon. And then we were off on a long journey, 9.5 years. The first step was to fly to the planet Jupiter for a gravity assist to speed our trajectory even more. That gravity assist shaved 4 years off the arrival time. that we would have gotten without it, and moved the flyby of Pluto and its exploration from the summer of 2019 back to the summer of 2015. After the Jupiter flyby, we flew the spacecraft for 8 years to that intercept with Pluto and its system of moons in the summer of 2015. And then since then, we've been exploring this disk of material called the Kuiper Belt, which I'll talk to you more about toward the end of the presentation. Now, I know this looks really easy. It's just a cartoon and, you know, the years go by, but you have to imagine that this was a 10-year enterprise in which we communicated with the spacecraft, controlled it, navigated it virtually every day for 9.5 years, and planned the flyby of Pluto to the most meticulous detail and tested those plans on simulators over and over and over again to work out all the bugs. And that was done not with the 2,500 men and women that designed and built and tested and launched New Horizons, but with the crew of New Horizons, if you will, the flight control and scientific team, which only measured about 50 people. By comparison, our predecessor Voyager had a mission team of 500 people. So during these 10 years, the 50 of us were very, very busy. We had to do the work of those 450 people on Voyager to make similar plans and to fly a spacecraft across the solar system. At our Jupiter flyby, we were very successful, not only in navigating the spacecraft to get that speed boost, but in addition to taking over 400 different scientific observations like these of Jupiter and its moons. This is an image of Jupiter made by the Ralph camera on board, and another image, again made by the Ralph camera, of the volcanic moon of Jupiter called Io. And this mosaic of those two images actually was on the cover of the Science magazine in 2007. Now let me turn to the Pluto flyby. This is a pair of pictures in our Mission Control Center, which is in the state of Maryland in the United States at the Johns Hopkins Applied Physics Lab where our spacecraft was built. And here you see my project manager, Glenn Fountain, in the Mission Control Center, and one of our flight controllers in the actual, the pit, we call it, where all of the commands are sent to the spacecraft to instruct it through the flyby, and where all of the data is received. Following all those years of planning, the actual execution of the flyby itself was a 2-year operation, spanning all of 2015 and almost all of 2016. It began in the winter of 2015 with navigation operations to home in on Pluto and to make course corrections to refine our path, and then proceeded through a hazard search to make sure that we wouldn't fly into any debris fields. And you can see each of the course correction maneuvers that were made along here for targeting purposes. And then we reached closest approach just about 7 years ago exactly to today. It was the 14th of July, 2015. Then after just a few days of intensive data collection as the spacecraft flew by Pluto, we turned back to the Earth and used that high gain antenna to begin transmitting all of that data back to the Earth. And that transmission took 16 months. It took until late October in 2016 to get all of the data that was on the flash memories, the solid state recorders, back to the Earth. So let me show you a little of some of the results from the flyby. This is sort of a family portrait when the spacecraft was still quite distant from Pluto, with its large moon called Charon, which of course looks very different from Pluto, and 2 of its 4 smaller moons. These are Nix and Hydra, that orbit much further away than Charon does. This is a close-up of Pluto and Charon, and these are in color, but the color here has been exaggerated just to bring out the contrasts in details. And I think you can see that although Pluto and Charon have been together orbiting in the outer solar system in the same radiation environment, in the same bombardment environment for impactors, and the same thermal environment, they are very different objects. Pluto is much more colorful, it's much more reflective, and it's much more geologically interesting and active than Charon, which is about half of Pluto's size. This is a close-up, actually a computer-generated close-up of a mosaic of images of Pluto wrapped onto a sphere to show you what it would be like if you were an astronaut aboard New Horizons with binoculars or a telescope looking at Pluto from closest approach. And this large bright area is that glacier that I showed you before. It's the largest glacier in our solar system. It measures about 1 million square kilometers, or about the size of the US states of Texas and Oklahoma combined. The glacier, called Sputnik, is surrounded by vast mountain ranges that tower as high as 5 kilometers above the glacier. Those mountains are made of water ice, and we know that because we fingerprinted their composition with the Ralph composition spectrometer. You can see a variety of different colors on the surface due to different types of surface materials. Some of them are ices, like frozen nitrogen and frozen carbon monoxide, frozen methane, natural gas here on Earth. But you can also see redder regions that are caused by the deposition of organics that silt out through Pluto's atmosphere, that are created by radiation chemistry in the atmosphere, and which silt out as fine particles onto the surface. And you can see other details of Pluto's geometry here, such as large craters, some of them with halos around their rims, and others with bright nitrogen deposits on their floors. You can also see large tectonic fractures in the surface at a variety of locations that we believe were caused by the impact with some Kuiper Belt object that excavated the entire basin in which this glacier sits, and caused these faults to relieve stress from the titanic impact itself. This is a close-up of a mountain range on Pluto. These mountains are about as tall as the Colorado Rockies, where I live. They're 3 to 4 kilometers in height above the plain. And what I really like about this image are the bright snow caps on these images. I think it's just incredibly haunting to think that there are mountains with snow caps on a world billions of miles from the Earth. But these snow caps are not made of water ice the way that snow-capped mountains across the Earth are. These bright snow caps are made of a different material. It's frozen methane gas, which is condensed at high altitudes on the tops of these Plutonian mountains. This is one of the roughest and oldest regions on Pluto's surface. It's actually at the juncture between the big glacier Sputnik that I've told you about and this dark region, which we call Cthulhu. And right at the juncture, we made an image to compare the two regions, and you'll notice the large number of craters. That large number of craters tells us that this is a very old structure, because the more craters on a surface, the longer it has been exposed to the cratering. This is a technique that's very well established in planetary science, and we can date a surface by the number of craters on it. And this surface, in fact, has been dated back to the birth of Pluto 4.5 billion years ago, when the planet first formed. By contrast, this area, which is in the heart of the glacier, it has no craters whatsoever. There are what we call cellular patterns, not because there's biology there, but a cellular geologic pattern that's caused by the overturning of the glacier due to a convective process in the ice. But what's more important is that we don't see any craters, and that tells us that this surface, even though it's directly next to the 4.5 billion year old Cthulhu, is very young. In fact, we searched the entirety of the glacier in high resolution images like this and found 0 craters anywhere on its surface, And that allows us to place a constraint, what we call an upper limit, a maximum age of just about 10 million years. And although that's very old by human standards, it's older than our species, for example. It's the blink of an eye recent in terms of Pluto's geologic history. So this tells us that Pluto is somehow active 4.5 billion years after its formation, which was a surprise because it's a small planet. We expected it would have cooled off and died like the Earth's moon billions of years ago. But Pluto is somehow still very active and creating these vast terrains, 1 million square kilometers of glacier, for example, in the very recent geologic past. And this is one of the major findings of New Horizons. We also found evidence for present day activity. This is a color-coded topographic map of the region at the eastern boundary of the big glacier and the mountain ranges that surround it. These are the mountains. This is down on the glacier. And here in this chute, you can see that there was an avalanche or a flow of some sort that pooled material that flowed out from the mountaintops on these plateaus down onto the glacier. And because we see no craters in that circular region, we know that this is also very recent. And there are other examples of avalanches and similar flows like that across Pluto's surface. Even more puzzling was the discovery of a variety of different volcanic features that spew ices out, not lava like we have on the Earth, but which spew ices. This particular cryovolcano is one in Pluto's southern hemisphere that is as large as one of the largest volcanoes on the Earth, called Mauna Loa in Hawaii. It's almost identical in size, about 150 kilometers across. It's almost identical in height, more than 4 kilometers tall. And you will notice that that volcano's shield, the circular feature around the vent, also has no craters. In fact, we've only found one. So this form of volcanism is also taking place in Pluto's recent past. More evidence for activity. We also found strange landforms that we've not seen anywhere else in the solar system, like these methane bladed terrains, and evidence for past liquids on Pluto's surface, like this frozen lake bed that was found in a hanging valley in one of Pluto's mountain ranges. Now I'm going to take you on a tour of Pluto with panchromatic or black and white images made by the LORRI camera at high resolution. We're going to fly across Pluto's surface from its North Pole or North Polar region across snow-covered polar terrains where you can see into Pluto's interior through those crater windows, across some badlands with the tracks of what we believe were tornadoes or dust devils, and then up onto mountain ranges and fractured mountain blocks until we reach the shoreline of Sputnik Basin, which you see here with that cellular pattern due to convection and dune fields across the surface of the glacier. Pluto turned out to be a scientific wonderland, and we are still analyzing the data from it. But we're now going on. The spacecraft is exploring the Kuiper Belt, and our first flyby of an object in the Kuiper Belt took place on January 1st, 2019. The object is called Arakoth, and it's an American Indian word that means sky. Arakoth is much smaller than Pluto. This is an image of Pluto, a map made from New Horizons images. I'm going to animate this, and we're going to fly up on the Pluto surface now in just a few seconds, and we're going to place Arakoth on the surface to show you how much smaller it is. It's really just the size of a mountain block on Pluto. And the reason we wanted to explore an object like this is that it's an ancient building block of Pluto and the planets like it out there. These are the objects out of which Pluto and the other planets of the Kuiper Belt accreted. And no exploration of any of those had ever taken place before. But we were able to find Arakoth with the Hubble Space Telescope, and then to hunt it down in the the late months of 2018, using our own navigation cameras and making course corrections. Here at the center of this magnified star field, ahead of the New Horizons spacecraft, still another 1.5 billion kilometers past Pluto, lies Arrokoth. And what you will see when I animate this series of images, as the spacecraft flew up to Arrokoth, is you will see it appear and first be detected by our cameras, and then grow brighter and brighter and move across the sky due to parallax as New Horizons approached and homed in. Watch for Arrokoth, and then watch it move and brighten. I'll play that again. And one last time. This takes place over about 100 days in the fall of 2018. And then for the actual flyby, we had success. We came exactly on top of Arrokoth so that our cameras could explore its geology and study its composition and search for an atmosphere around it. This is a live picture inside our science room at 3 in the morning on January 1st, 2019, at the moment that the first high resolution image of Arrokoth was received on Earth. Here's a better image of Arrokoth. It's called a contact binary. That's a type of object that has two lobes that formally orbited one another and that came together, as you see at this seam or neck between the smaller lobe and the larger lobe. And what Arrokoth, which you see here in color and a geological map of it, has done for us is amazing, because it's taught us about the accretion processes out of which these building blocks of planets were made, and gave us the first look at an ancient and pristine building block which had been kept in the deep freeze of the outer solar system for all these billions of years. And we're still getting data back from this flyby more than 4 years, excuse me, more than 2 years after the flyby, and it will take another 2 years until 2023 to finish transmitting all of that data back. But meanwhile, we're looking for yet another flyby target using large ground-based telescopes. And I'm going to conclude my presentation here with this beautiful picture. It's my favorite picture of the entire New Horizons mission. It's a true color picture taken by New Horizons on July the 14th, 2015, looking back at Pluto after we passed by it. And what you see in that blue ring around the planet is sunlight filtering through its blue atmosphere. And I think it's very pretty, but the reason that I like this image so much, and I wanted to end this presentation here on Asteroid Day with it, is because for those of us who worked on this mission, it took 26 years from inception in 1989 until this picture was taken on flyby day in 2015. And 26 years is a long time to work on something. But actually having an image from the far side of Pluto, which is what this is, to me is the crowning jewel of the exploration. It's a picture that can only be made when you've accomplished your goal, because it can only be made on the far side of Pluto. And I just find this to be iconic of the persistence and the talent and the little bit of good luck that this team had to carry this mission of exploration out and to do it for all mankind. And with that, I'll say thank you. I'll stop sharing, and we can do questions and answers.
Thank you, Alan. It was fascinating.
You're very welcome. Thank you.
We have a questions from audience. First, how do a nuclear battery launched?
You mean how is it launched, or how does it work?
How is it launched? And the question is, how is it not going to explode? Or
a good question. So this battery cannot explode. It doesn't have a critical mass of plutonium required for a weapon. So there can't be a chain reaction. But the plutonium is toxic. And were the rocket to explode, then we don't want that toxic material to get out into the Earth's atmosphere or the ocean if the spacecraft were to fall in the ocean. So these nuclear batteries are built to be very strong and to be capable of surviving rocket explosions. In fact, one was on a rocket that exploded a long time ago, and the device not only survived, but was completely intact. It was pulled out of the ocean, completely working, and it was later relaunched on another mission. That's how tough they are.
Oh,
So this is meant to be a very safe process.
that's great. How does New Horizons avoid collision with micrometeorites and larger objects?
Well, that's another good question. Thank you, Itai. We can't avoid impacts with tiny objects, grains of sand, for example, but that the spacecraft, and you see a model of it here, you remember is covered in that gold foil, which I said is a multi-layer insulation blanket. But that multi-layer blanket also includes several layers of Kevlar, which is the material in bulletproof vests. And so when we are struck by a tiny grain of sand, which happens all the time at a very high speed because the spacecraft is moving so fast, those Kevlar jackets protect the spacecraft. As to larger things, if we were to be hit by something even the size of a rice pellet in your dinner, it would destroy the spacecraft. Oh. And fortunately, space is very empty, and we can calculate the odds of that happening, and they're very tiny, even when we fly the mission for 20 years. So we have no protection except the fact that everything is so spread out in space. The odds of having a catastrophic impact are very low, not only for our spacecraft, but for others.
And that, so we protected because space is big.
Yes, like, and it's empty. And that's why we call it space, right? I think it was not meant this way, but of course, in the Old Testament, there was a phrase about empty of empties, you know, and this is exactly what space is. It is almost entirely empty.
Okay. Is it possible to install a telescope device on an asteroid that moves between different solar systems and take advantage or it to observe other solar systems?
Yeah, that's a clever idea. There are asteroids and comets that float between the stars. And the first one, although this was theoretically predicted decades ago, our technology only allowed us to make the first detection a few years ago, late in the 20-teens. We've now found two, but we know that if you found two, that there will be many more as our technology improves. And these asteroids do cross the gulfs between stars, but they're moving very slowly. So it takes them millions of years to go from one star to the next star. They're moving fast by human standards, but slowly compared to the distances between the stars. So a better approach would be to build a spacecraft with a big telescope and to fly it with advanced propulsion to another star system at an even higher speed, so that the journey didn't take millions of years, but perhaps only years. Now, we don't know how to build that propulsion system yet, but perhaps in a century we will.
Possible. Did you encounter asteroids in the asteroids belt on the way to Pluto?
Well, that's a really good question too, 3 for 3. So in fact, we had an opportunity to make a flyby of an asteroid just 4 months after we launched in May of 2006. But it would have required spending some of our fuel supply, a large amount, to home in on it. And I decided that we wanted to save the fuel for what we were really built to do, which was more flybys in the Kuiper Belt. And I'm glad we did, because that amount of fuel, had we spent it on the asteroid flyby, would mean that today New Horizons would be out of fuel. And it would be impossible for us to have another Kuiper Belt object flyby, which is what we are now hoping to have.
Okay. Does New Horizons have an extended mission before leaving the solar system or running out of fuel?
Yes, we're on the first extended mission right now, which NASA approved in 2016 and which will continue until October of next year, 2022. But we have a healthy spacecraft and we have the fuel and the power in the nuclear battery to continue to explore for at least 15 more years, maybe 20. So if NASA continues to fund the mission, we'll have a second extended mission and hopefully a third and a fourth.
With the same spacecraft?
Yes, with New Horizons. It's doing very well. The only thing that we're afraid of running out of is money.
And how much correlation there's between the plans on the way, for example, the depth of the researching Pluto, and then the results on the real time?
Well, you saw that Hubble Space Telescope image so blurry of Pluto. We really didn't know what to expect. And so everything was new. That was part of the scientific, fun, in a sense, is that it went from a smudgy little image to a real world in just a matter of days. And everything that we found, from glaciers to mountain ranges, to secrets about Pluto's atmosphere, to the history of its geology, was all new. And there was no really competent set of predictions because we knew so little. So it was purely first-time exploration.
Wow. And from your knowledge and your experience point of view, what do you think is the most important challenge we must undertake in the coming years?
I'll answer that in terms of space exploration, although there are other important challenges to humankind, of course. But for space exploration, I think it's to become a multi-planet species. As Elon Musk likes to say, to have a backup to the Earth, to establish human colonies in other places. I think this will be important for science. It will be important for our view of ourselves as a species. I think it'll be very important economically, because just like the settlement of the Americas has driven the world economy over the past few centuries to new heights that were not possible before. The establishment of bases and then colonies and then cities on the planets and among the asteroids, I think, will open up vast new business opportunities that we can't even imagine for the 23rd and 24th centuries.
I have a few, two questions about the Virgin Galactic mission. How many people are going to be there with you?
Say that one again. It was too
How
faint.
many people are you going to be with you there?
I don't know the answer to that. Virgin hasn't told me. What they've said is that I may fly with others, or I may be the only one besides the pilots, because they haven't decided if there will be tourists on the mission or other scientists, or maybe just robotic payloads.
Oh, and the question about other experiments besides NASA.
What's the question?
Will you do any other experiments besides?
You mean on the Virgin Galactic flight?
Yes, but
yeah.
Okay.
Yeah, I'll be doing two experiments on that flight. One is a biomedical experiment, and the other is an astronomical experiment. And they're both built and ready to go.
Waiting for it. Thank you very much, Alan. I finished my questions.
Well, thanks. Those were all great questions. I really appreciate that and had a lot of fun. Victor, I guess I'm giving it back to you.
Yeah, so thank you very much, Alan, for a brilliant talk and answers for all our questions. It was really inspiring. And of course, we're waiting to hear all about your adventure in the Virgin Galactic voyage. If you ever come to visit Israel, all of us will be happy to meet you and to speak with you, of course. I want to thank again my partners to this Asteroid Day Israel event, Itai Leon, the incredible astrographics artist, for all the event's graphics and the Q&A session, Adi Saada, the manager of the Horizon community of space educators and professionals by ESA, for the use of their Zoom platform and Facebook Live account. And of course, Mach Tabit for all the help with the event organization. Also, I want to thank all of you attending Asteroid Day Israel event. You can continue watching Asteroid Day TV on asteroidday.org website. See you next year on the next Asteroid Day event.
Thank
Bye.
you so much, Alan.
Thank you all.
Thank you very much.